Tuning out. The science of noise cancellation. Which is the better environment for studying? A noisy place or a quiet place? Rarely do people want to put up with a lot of noise because it can be unpleasant and distracting. Fortunately, scientists have invented noise-canceling technology, which is now being used across various fields to reduce unwanted noise. What is the scientific principle behind this achievement? To understand this, let's examine how sound travels. The principle of sound waves and interference. Sound is produced through vibrations that occur from a sound source, when the strings of a guitar are played, for instance. The vibrations of the sound source cause the air to vibrate and the sound to travel as waves, similar to the ripples created in a lake when you throw a stone. When these sound waves reach our ears, the brain interprets them as sound. Just as different ripples in water might overlap if you throw two stones, sound waves can also interfere with each other when they meet. There are two types of interference, constructive and destructive. Constructive interference occurs when the peaks of two waves overlap, resulting in a bigger wave and a louder sound. Destructive interference, on the other hand, occurs when a peak of one wave overlaps with a valley of another wave, so they cancel each other out and produce a quieter sound or no sound at all. The science behind noise-canceling headphones. Destructive interference is used in the noise-canceling feature of headphones when we listen to music. Inside the headphones are microphones and noise-canceling circuitry. The microphones pick up sounds from the outside, and the circuitry analyzes them to produce opposite sound waves. For example, if outside noise has a value of +1, the circuitry will generate an opposite noise of -1 and transmit it to the speakers. This cancels out the unwanted sound even in noisy surroundings, so you can hear the music sound clearly without turning up the volume. However, it is not easy to entirely eliminate external noise with this technology. To achieve full noise cancellation, the circuitry must convert the noise into digital data and instantly transmit the opposite sound to the speakers as soon as the noise reaches the microphones. Therefore, this noise cancellation technology is effective for predictable sounds like those of car engines and subways that occur regularly or over a period of time. However, it's relatively less effective for inconsistent sounds, such as those of people talking close to you. Exploring the technology and its applications. Noise-canceling technology is not only used in music devices. Other fields also take advantage of this technology, such as ticket offices at tourist attractions, which are often very noisy. Microphones are installed in ticket offices to detect external noise, and an opposite sound wave is generated and transmitted through a speaker, enabling the ticket agent to hear the customer's voice clearly. Another area in which this technology is used is drive-through fast food restaurants and coffee shops. They use noise-canceling headsets to improve communication between employees and customers by eliminating vehicle noise. These noise-canceling headsets help drive-through employees take orders accurately. The same technology is also used for cars, whose audio systems generate waves to cancel out unpleasant sounds such as engine, wind, and road noise. Thanks to noise-canceling devices, it is possible for drivers to focus on driving without being disturbed by distracting noises. As technology advances, many people expect it will solve various social issues caused by noise pollution. A common source of these problems is noisy neighbors, as the noise they make can lead to conflict among residents. Noise cancellation technology can help address these problems by reducing unwanted disturbances, allowing people to lead more peaceful and healthier lives.